Help me out. What else did we see there was to a parabola besides the HK, besides the vertex? Wait, hold on. How can we find the vertex if we have some just general ambiguous parabola? Yeah, you can plug it in, John. How can we find the vertex? Let's just review. Do you want me to give you an example? Would that help? What if I was to give you something like x squared minus 6x plus 13. Okay. X squared minus 6x plus 13.
Find the two.
Find the, yeah, I guess we could find the two zeros and then find the midpoint, because zeros are going to be symmetric if we find halfway in between zeros. But some parabolas don't have zeros. Is there another idea? That could work if it had zeros, if it had two zeros. If it had 1 0, what would be at the 0? If a problem had 1 0, what would be at the 0? The vertex. So I guess if there's 1 0, we found the vertex. If it had no zeros, we're sunk. Okay, look at that worksheet. How did we find vertices? There were two different ways. On one section I said you could use a formula, and on one section I said you could complete the square. So what do? Yeah, so Patricia, remind me of whatever you remember about completing the square. That's okay. Someone else help out. She got the completing the square part.
You subtract 13 from each side, and then you do negative b over 2 squared, and then you add it.
Okay, let me take that. The b over 2 squared. Just because I don't have another side right now, I know what you're trying to say, but hold on. B over 2 squared, I agree. What do we do with that 9?
So that would be x squared minus 6 plus 9.
So x squared minus 6x. That's one way. Just for sake of being able to apply it to any problem, what Joseph is seeing is that we can split the 13 up into 9 and 4, and the 9 we're going to use. The other way that we could do it that's a little bit more broad, a little bit more general, is that we could go ahead and put the 9 in, keeping the 13, but how would we make it balanced? We would not just add a 9, we'd also have to, yeah, if we're staying on the same side. If we have two sides, we would move the 13 and add 9 to both sides. But since we don't really have another side, we have to offset it, so instead of adding, we're going to subtract. So Joseph is ultimately right. It is going to end up being x squared minus 6x plus 9 plus 4. Now what? Mm-hmm. And when you factor x squared minus 6x plus 9, what do you get? Uh-huh. Uh-huh. All right, kiddos, what's my vertex? Careful. Oh, I just didn't even look. 3 and 4, you're right. X minus h plus k. Does anybody have a nifty little trick formula that might help us get there a little bit faster? I wrote it down yesterday. It's in your notes from this section. I said you could also find the vertex in the review part. H equals negative who? All over 2a. So you could have plugged in 6, negative 6, all over 2a, which is 1. Wouldn't you also end up with 3? And wasn't 3 the x of the vertex, or the h? But wait, hold on, we need k. How could we find k if we plugged into this baby formula? Who is k? He's not the x value, he's the... Uh-huh. And what's this whole function equal to? So how would I find the y if I have an x? The easy stuff becomes hard. How do I find y if I have an x? Say it louder. Plug it in. So if you go plug the 3 in, what would my k be? It would be f of 3. So plug in 3. What's 3 squared? 9. What's 6 times 3? 9 minus 18 is? And negative 9 plus 13 is? It's okay, so quickly we forget. Does that make sense? We can find the HK using completing the square. We can find the HK using formulas. Well, formula and then plugging in. So a vertex is something that we learned way back when. We just, had gotten really rusty at it. But what are some new characteristics of a parabola? Now that we've reviewed the vertex stuff, what are some new characteristics we saw yesterday? A focus and a directrix. Now, with the focus and a directrix, is there a whole, that's the old school stuff. Hey, look, it's the little formula I wrote down. Anyway, so we could use the little baby formula. If you guys need to write it in your notes, it might be helpful at some points. You can take negative b all over 2a to find the h. To find the k, we would need to plug in h and solve, right? We would need to plug in the h and solve. That was using the baby formula way. The other way that we reviewed would be completing the square. And guys, did I mention completing the square yesterday? Okay. Quick word to the wise. Just life lesson, thinking ahead to maybe some really hard classes you might face in who knows what field you might be going in. If a teacher ever introduces a concept and says, oh, you should know this already, and goes past it, what do you think if they don't actually review it in that moment? You should probably do that night. Go review it, because if they brought it up, they're thinking it applies somehow, and whether or not it applied that day, it might apply the next day, and if you don't ever review what they assume you know, what might end up happening very soon? Well, you just get lost, right? I mean, maybe it'll lead to failing. I mean, I hope not. I hope that you would go get tutoring or help from their office hours or something eventually, right? Reach out to someone in the class that at least looks smart if you don't even know anyone yet. Be like, hey, how you doing? Want to do homework? Make friends. Make acquaintances. Maybe not friends because maybe they're not friend material. But you know what I'm talking about. So anyway, coming back. Beware the kids that sit in the far back and are really, really quiet. You might think they're the nerdy ones. They might also be the very high ones. Just be careful. Life lesson. Just choose friends wisely. Choose friends wisely. That came out of an alumni story. They're like, yeah, I thought they were the nerdy ones, and then I was like, oh, as soon as they open their mouth, they're like, well. But the person would like try to get answers from them the rest of the semester. It was rough. Okay, coming back. So you do need to reach out. Don't be an island. Don't be by yourself, and don't be like, I'll do it on my own. But what was I saying? Why was I saying it? Don't
get lost.
Don't. Do you guys hear this?
Yes. This is your brain. This is your brain on drugs. On food drugs.
I'm going to quickly just save everything real fast, if you guys don't mind.
This was all on recording. Anyone who was at school.
Yeah. Good life lessons, right? We're just hoping everything's going to be all right. Let me just close this a little bit, just in case.
Just in case it blows.
Just in case something. Don't worry, there's a fire extinguisher right there. We'll know how to do it. I'll have something. I can use paint or a book. Here we go. Shh, coming back. Long story short, I reviewed. I didn't review entirely. Did I teach you complete the square yesterday? No, but I mentioned it enough times that you guys should have reviewed it last night, okay? And it's okay. You're still in high school. You're still in like the teacher spoon feeds me everything mode, sort of, unless you're in an AP class where you're like, I kind of have to work on my own, but still we have really good teachers here that try to give you everything you need. College, not necessarily like that, okay? So if they bring up something, they say, oh, you guys know that, and move on. If you don't be ashamed. Just be like, I will tonight. Anyway, so here we go. How to find the vertex we already talked about. You guys mentioned that there's a thing called a focus. A focus, what was my hint yesterday? Where's the focus always? Inside the concavity, right? Focus is always inside the concavity. If you guys are good at visualizing, this will make all the difference as far as either how to find the focus or how to find the parabola given the focus, and we saw that yesterday. The focus, one point, always inside. So if it's a right-left, it'll always be to the right or to the left. If it's an up-down, it's always going to be up or down. It's a point that has an x and a y, and the x will always be somehow either equal to or dependent on the h, and the y will always either be equal to or dependent on the k. And who is this little p guy? We find him from setting up the formula in a very particular way, but what does it represent? It's quiet. The distance to the focus. Remember, you focus on the point. You look at the point. And if you're looking at the point, the p is always the distance to the focus. Now, what else can p be used for, though? Not only going straight to the directrix, but also going straight to the, going straight to the focus. But also, I can go backwards to the directrix. And the directrix is, for any point on a parabola, however far it is to the focus, you go the exact same distance to the directrix, perpendicular. It's always going to be a horizontal line. In an up-down parabola, it's always going to be a vertical line in a right-left parabola. But you go p backwards from the vertex to get to the directrix. It'll always be an equation of a line, hence the x equals y equals. The x one will be dependent on h, the y one dependent on k. So is hk important? Yes, make sure you have a way to find it. Okay, we did some examples yesterday. Hopefully he's happier. I talked about this whole page. Could you memorize the whole shabam? Or you could learn how to visualize and use the clues. But you're going to have to find a way. Does that make sense? Okay. We did examples of giving clues, but we did not get to applications. Let me go ahead and zoom in on this guy real fast. We talked about the flashlight just for a moment. Let me go back to that page real quick. Okay. Do you guys see what I was talking about as far as a flashlight versus a lamp? A flashlight directs, a lamp just diffuses. Diffuse might not be the right word, but that's okay. Lights up a whole room as opposed to a flashlight that just lights up a certain area. This parabolic reflector with the light source at the focus makes it that all the light is directed in one beam. Does that make sense? Anyway, practical application of not only a parabola but also a focus. Where's the directrix? Anyway, but practical application of a focus and a parabola. So, coming back. We have one more big idea. And this big idea, let's just say if I could teach you calculus today, it would be so much easier. But I can't teach you calculus today for a couple of reasons. So instead, we're going to learn what came before the calculus. What came before the calculus? If you look at any early math discoveries, there were certain conditions that they had to use. And it almost always had to do with what can be proven with a ruler and a compass. Was there a third object? A ruler and a compass. I think that was it. What could be proven with a ruler and a compass? Which is why you guys had so many things in geometry. It's like, oh, I could do this with a compass, and I could do that with a compass, and I could do... Anyway. Protractors, I think, came later. So we're going to take a geometric approach to this instead of a calculus approach to this. And look at how complicated it could be without the idea of a limit. Ooh, limit. We've talked about those before. That's the calculus part, though. What you guys are writing down right now is that we are going to figure out how to find the slope of a tangent line to a parabola at a point using geometry. Using geometry. And the geometry of a parabola, we're going to be using specifically the parabola itself, a point of tangency P on the curve. The focus and the point at which a line drawn through P intersects the axis of symmetry. Let me go ahead and label a few more things that might be helpful. For any parabola, ooh, that's not right. We know that the vertex is going to be HK, which either they give us or we could find. And if the vertex is HK, we could say the axis is x equals h. The axis of symmetry for this specific parabola would be x equals h. I could say that the focus, guys, hold on and help. What could I say as the equation of the point for the focus based on what you see? How would I find the focus? Go ahead, go look at the yellow box. This is an up-down parabola. I put a picture in that yellow box of an up-down parabola. What's the formula for the focus? No, it needs to be a point. It needs to be a point. You're looking at the directrix. Look at the focus. Good. H stays the same, K changes. Think about it. Did this move horizontally at all? No. So H is still the X value. Did this move vertically at all? Yeah. K needs to add, oh, remember P is the distance. Okay, K plus P. So if we have the vertex, got it. If we have an equation, cool, let's find P, and then my focus is going to be H and K plus P. If I have a point of tangency, which they're going to give me, P is going to be given. I'm just going to put that in parentheses. They have to give you the point that you're working with because these slopes of the tangents change dependent on what point you're at. So that's going to be given to you. Now here's the dealio. If, according to this picture, if this is an isosceles triangle, if these two angles are congruent, what do we know about their two opposite sides from geometry? If the angles are congruent, what's true about the sides? They're also congruent. An isosceles triangle is going to have two congruent sides, right? Sides opposite congruent angles will also be congruent. So here's the dealio. To find the equation of any line, I need to have 2 points. If I have 2 points, I can do y minus, I'll call this, let's do y minus y1. For any slope, we need two points. And so then for any equation of a line to get the slope, 2 points are needed. And then in the actual equation, only 1 point is needed. We'll probably always put point P as our point of tangency, our x1, y1. But here's the struggle. If P is 1 point on the line, we need a second one. And the problem is this line will only intersect the parabola in one place. It skims it like a tangent line to a circle. And so if this line only skims the graph at 1 point, how are we supposed to find the second point? It's impossible for us to find this equation of a tangent line using geometry and algebra without a second point. But what do you see based on the other nature of the parabola? What do you think is the other point we'll be able to find? Something out here? No. But what about that guy? You guys problem solve with me? If we need 2 points, I'm not given anything else. Neither of these points are on the line. They shouldn't be on the line. It's skimming way over here. What do you think we can do to find this point? Any ideas? Distance formula. We don't know him. This is the big unknown. This is the guy that I need. This is going to be my x2, y2 once I find him. But we don't know him until we get there, and we can't get there until we say, wait a minute. What if we find the distance between these 2 points? Let's pretend that was actually a nice D and that I can write on my smartboard. Distance between my 2 points. Because I'll know this point, it's given. I can find the focus. Distance between 2 points, fine, whatever. I mean, that's algebra, right? D equals the change in x squared plus the change in y squared. I can find distance. Once I find distance, what can I do? Congruent, yeah. So if it's congruent, can't I just go down that distance from the focus? Wait, down. Is that changing horizontally or vertically? Okay, so this point, isn't it going to just be h? And what would my y be? K plus p minus d. Now, could you memorize that? I suppose. Do you want to just see if you can do it? Let's just see if we can do it. But do you see the idea? The idea is, if I can go to my focus and then go down to where the tangent line connects, and if these distances have to be equal, which they will, it'll always form an isosceles right triangle. Sorry, not right triangle. An isosceles triangle based on the nature of a parabola. If we just find that distance and then go down, boom, we have a second point. Ha-ha! With 2 points, I can make a line, dun, 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 dun. And not just any line, a tangent line that theoretically is impossible to find any other way, because you can't just find a line with 1 point. Or can you? All right, here we go. I want you guys to graph what's going on. And as we talked about, the focus is super important. So don't only graph y equals x squared, don't only graph the point 1, 1 and where it hits on y equals x squared, but also see if maybe possibly you can find the focus. Ooh, this equation is almost so easy, it's hard. Look at yesterday. Look at the right way of writing it so that you can find p. This one's almost so easy, it's hard to find p. The odds, I'll probably count the evens for today. All right, who's found what? Give me something. Where's the vertex? Let's start there. Good. And how should we have rewritten this guy in order to find P? What did you guys do? He's an x squared one, right? Where is that normally written in our p form? Is it on the right or on the left? The squared one? The left. So we could do x minus 0 squared equals y minus 0. Does that help a little bit? Look at the box. I don't want you guys to be totally lost. I could keep scrolling back, but you guys have it in your notes. Go back and look at the box where we wrote down the formulas for the focus and the directrix. Where's the 4p? Yeah, next to the y minus k. Do you see it? The 4p is supposed to be right here, but look at mine. What's in front of the y? Okay, so what does p have to equal? Right? I rewrote it to be in the standard form. with the squared term on the left, comparing it to the formula. I can scroll back. Some of you have really blank looks on your faces. I'm not sure if you're looking where you're supposed to be looking. The 4p is always next to the non-squared term. It's the coefficient over there. All the coefficients gets moved right here next to the non-squared term. That coefficient is 4p. Do you guys see what I'm referring to? Answer out loud, yes or no? Yes. Got it. So then coming back, what was in front of the y? A 1. What was it supposed to be equal to? 4p. So what must p be? 4p equals 1, so p equals 1/4. Are we good? Whew. All right. So then, we have the point 1, 1. We have our parabola. If I can get an arrow. There it is. We have our focus, which would be... You guys good with that being the focus? That'd be 0, 1/4. Okay, I can't do it. Sorry, I've been trying real hard. It was good in period 1, and then it was okay in period 2. What's the coordinate for the point P then, guys? If it's 1/4 up. Good. So I have, I'm not used to it actually being on, maybe. Okay, 0, 0 is my center. 0, 1/4 is my P, right? Okay, why do we find the focus? What's the point? What's the objective? What do we do with it? That is the point. Anyway. Good, I'm trying to find the distance between... There we go. Between that and the point of tangency. So how do I find the distance between, well, wait, what is the point of tangency? 1, 1, right? Okay, so then I could go off to the side. I could do a quick little distance formula, plugging in y2 minus y1 squared plus x2 minus x1 squared. Addition's commutative, so you could have done the x's first, then the y's, either way. We end up with d is equal to, has anybody done this work? What do you get? No? Okay. 1 minus 1/4, 3/4. 3/4 squared would be 9/16, right? 9/16 plus 1 squared is 1. That'd be 16/16, which would equal 25/16, which would be 5/4. Good. So d is equal to 5/4. What can I do with that d? Follow the picture. What do we do with that d? Go down. Good. Let's go down 5/4. When we go down 5/4, what point should we end at? Good, 0, because it's the exact same x. And then what's 1/4 minus 5/4? -1, right? And then what can we do with those 2 points? Make our, what are we trying to be finding? Tangent line. There it is. Because we did 0, 1/4 minus 5/4, which was -4/4. Is that good? Okay. As you guys are hopefully going with the line, because that's algebra 1, yeah? 2 points make a line. All right, so anybody finding m? Double check me. I got -2. No, +2. We should be able to look at that line and see it's a positive slope. My bad. You guys agree? Cool. And then I'm going to go ahead and just use my point of tangency because it's easy, it's given, I know for sure I'm right. Check it. I want you guys to go ahead and graph in your calculators y equals x squared. And graph, well, we could get y by itself, right? That'd be 2x minus 2 plus 1 minus 1. Is this hitting the graph at 1, 1 and skimming it there? Y equals x squared. Y equals 2x minus 1. Let's see if it works. It's skimming? Okay, now I want to introduce you guys to a really cool feature. And I feel like I've done it earlier this year. I don't know why we would have done it, though. So maybe we didn't. Maybe I'm just thinking this is normally when I introduce this button. I want you guys to go to the math menu. Sorry, not math. You're in your grapher, right? I want you to go to your second trace, your calc menu. Oops, I'm in sequence mode. Hold on. Function mode, please. Thank you. Oh, nope, that's just connected. There we go. I want something that says either D derive. Second trace. There's my graph. Go say, hey, what's going on at 1? X. Yes. This represents find the derivative at a point. Derivative, super important word in calculus. Number 6, I want you guys to plug in or enter 1. This is like when you're finding a value, you have to type in 1, then hit enter. What do you notice? dy dx is, what did the slope end up being of our tangent line? Ooh, that's pretty snazzy. So I want you guys, instead of picking at 1, can you go ahead and do that again? Let's go ahead and do it at 2. Go ahead and hit dy dx. Solve for it at 2 now. Solve for it at 2. Question, what do you get? Uh-oh, I think I got 4. You guys got dy dx, plug in 2 this time, type 2 and hit enter. 4. Huh. Question, if we were to find the tangent line at x equals 2, what point would that be at? X equals 2, what's y in this equation? 4, 2, 4. So we would do this exact same thing, except now we would have, come back to your y equals. Let's change our tangent line. We saw that the dy dx was 4. Let's do 4 times x minus, now x is 2, and we plug in 2 squared to be 4. Let's see if this line skims. But now it's not going to skim at 1, 1. If we've done it correctly, it's going to skim at, it's going to skim at 2, 4. Huh. What do you guys think the slope would be of the tangent line at 0? What if we were doing a skimming line at x equals 0? X equals 0? Careful, that's a vertical line. Y equals 0 would be the skimming line. It looks like the x-axis or the y equals 0 is the skimming line. So what does that mean our derivative should be, our number 6, should be at 0? What would the slope be? Exactly. Nicely done. And why are slopes of tangent lines so important without me going full-fledged into calculus? Because it helps us find the rate of change at an instant, the instantaneous rate of change, versus what we've been doing so far, which is all just average rates. Anyway, super snazzy. Slopes of tangent lines or instantaneous rates can be applied in chemistry. They can be applied in physics. They can be applied in, all sorts of way in economics. They can be applied anyway. Lots of different fields. Kiddos, let's play. Homework help, let's play. That was the last big topic, the equation of the tangent line. But let me pause, let me breathe, and let me ask. Does anybody have any questions as far as how we got to this equation on this example? Okay, then let's see. Can someone walk me through the steps? Step 1, what did we do? Raise a hand. What's the first thing you saw that we did? Kevin. Good, we found the vertex. Step 2, John. Yeah, we sketched. We sketched the parabola and we sketched the point. Step 3, Ryan.
Find the focus by finding P.
Good. So we rearranged, figured out who P was, and then used it to find the focus point. Good. Step 4. Find the distance from? Good. From the focus to the point. Good. Find the distance. Step 5. Subtract that distance from the actual focus. Now this one we were going down, so we were subtracting from y. What if the parabola was shifted this way? We wouldn't add, we would subtract still, but we'd subtract from the x, not from the y. Does that make sense? So we subtract the distance to get the other point, and then what do we do once we have the other point? Step 6. Find the slope. And we can kind of like make that whole thing, use the 2 points to find, use the 2 points to find the line, right? Find the slope, plug in the point, make the equation of the tangent line. Okay, let's play. Number 32. And or 44. I know, guys, hang in there, but I can't turn the air down much lower. The temperature thing is off, I think. But should be coming on soon. To be honest, looking at 32 and 44, 44 is kind of probably the harder one. How about you guys in your groups? Take the next like 1 minute, maybe 2, in order to get this written in a proper form so you can find the vertex and identify the focus and directrix. Work together. My hint would be go look at that box. Yeah. Go look at that box. You might want to start with a picture, though, because a picture would at least give you an idea of which camp you're putting it in, the up-down camp or the right-left camp. Let's help each other. Up-down or right-left? Right-left. Why'd you know? The y is being squared. Good, not the x. Okay, sorry, go. What can you find? I'm going to pause the video as you guys work. How's my analysis so far?
Did you write that all in business?
Kind of. Do you guys see why I put y minus 0 and x minus 0? What's my one typo? Because I couldn't figure out how to erase it, but now I can. There's one typo. Righto, whatever. There shouldn't be a squared, yeah. The y is squared, the x isn't. But my analysis of 3 must have come from 4p, so p must be 3/4. Make sense? Cool. So then the focus, hold on. I drew my picture. I know this is going right. It's a horizontal axis of symmetry. I know it's to the right because there's only positive numbers. My focus needs to be to the right also. I'm so not used to this being oriented. Anyway. My focus will be to the right. My directrix will be to the left. So what did you guys get as your focus point? Who stays 0? X or y? Y is 0 because it doesn't go up or down. What needs to change? X. And how much does it need to change by? 3/4. So 0 plus 3/4? 3/4. The directrix, why did I put x equal? The vertical line. And it needs to be back what distance? So it's going to be 3/4, so x equals -3/4. Dun, 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 dun. What you know? Oh, I thought of, is there any plus or minusing going on? And since the answer was no, then it was 0. 0, 0. Why is the next example a little bit harder? So why am I going to go ahead and start by doing this? Yeah, because don't I want the squared guy to be on the left? But I need to complete the square to make it something where I can get my, it's going to be x minus h squared. We should. I was just going too quickly. I was supposed to subtract the 8y and subtract the 9. What's the number that's going to go in my blank to complete my square? -2 cut in half. -1 squared. +1. Like one side I do to the other side. Now I'm going to have x minus 1 squared equals -8y minus 8. I'm not quite to my standard form, but oh, how close I am. What do you think the last thing is I'm going to do? Factor out a -8. Because I need my coefficient in front of my y minus or plus k term. So then what's going to be basically the only difference from the example up above? What's my vertex going to be?
1, -1.
But aren't I still going to have to set this guy equal to 4p? My p is going to equal -2. I need to think about my graph and say, oh, wait. So 1, -1, this guy's like down here somewhere and he's facing up somehow. But once I have that, I know my vertex is going to be up, my directrix is going to be down. My x stays the same. My y, ooh, -2. Isn't that how I get to my focus? What's the struggle? The negative was over here. Guess how my parabola is facing? Down. All right, cool kids. I'm just going to finish this so that it's on the notes if you want to see it. My parabola is facing down, so my focus is down, and my directrix. Oh, someone help Colby if he needs it. Y equals -1 plus 2, which would be +1. Yep. Homework due tomorrow. Bye. Yeah, kid. Let me go pause my recording real quick.